So, in this video, I will demonstrate the type B workflow executor. Towards this, I have already applied the map construct to the word length calculator and the reduce construct count words by length built-in workflow with the length as a key. I have already shown in the last video how I applied those two constructs. There are few points that I want to make a note here before we proceed to the demonstration. The first one is, in my implementation, the collectional data product visualization is not done yet, and hence I will show the data in the table directly. Okay. The second point is the number of machine is set to 3 for now in EC2 Cloud. Although the number of machine can easily be changed later in the code and made dynamic based on the data size. But for now, for this particular implementation, I have set it to 3 machines. Okay. All right, so let's go through the demonstration part now. First, I will show the input of the C workflow. The input of the C workflow is same as the input of not the map, but input of the word length calculator, because it is the first task, right? So if you see in our data view, so this is the workflow that we created in the last video. So the input here is a collection. Okay, so the input collection is it's called the word list, and it's connected to the first task here, which is word length calculator. Okay, so the input of word length calculator is word list, and I will show you the input of the C workflow. So let me log into my database. So this is the word list section, right? It has one key, and the key is unique number, and then the value is word, the list of the words here. Okay, and then there are 9 rows in this section. Okay, so let's go ahead and quickly see in our data product specification repository. Let me go ahead and delete all my previous outputs so that so we can run the workflow again. Okay, so this is the word list collection, right? Let's look at the DPL again. So the DPL has the schema definition here. Schema is key and of type integer, and then word of type string, like what we discussed in the last video, right? And then the reference is go to the meta table word list. I already showed you the meta table. It contained 9 rows in it. Okay. All right. So that's the input data for the C workflow. Okay. The next one, I will run the workflow in 3 virtual machine in EC2, as I said earlier. Okay. And the workflow consists of 2 tasks: word length calculator and count words by length. So let's go ahead and run the workflow. Let me quickly refresh my screen. All right. So this workflow has 2 outputs, connected to each of the tasks. So let's go ahead and click run button. Here I will make a selection of type B. Okay, and then when we click submit, let's go ahead and look at our console to see everything is all right there. Yes. Okay. So the workflow is getting executed. Let's give a couple of seconds. Okay, so workflow got executed. As you see, the two collections are generated here. So let's go back to our nodes. So now I will show all the input partitions, also known as the inputs, for each of the map word length calculator, and the output collection generated from each of the map word length calculator, right? First thing first, let's look at how the input partitions are generated. So if you see in go back to our connection. So I showed earlier input data set, right? The word list meta table that had 9 rows. So you see now there is a 10th table created here, and for each of the keys, we have it as a partition key. So we generate a second, and then we assign so based on the ring, sometimes you get all three machines used here, and sometimes you just get two machines used here. Again, it depends on how the tokens in the ring are distributed. Okay, so for now, let's look at these the data created as two partitions, right? So if we look at our the cloud database, so let me go to the cloud data node 2. If I go to collection of DPS, we have a word list here. So you can see there are 1, 2, 3, 4, 5, 6 rows in this partition, right? So that's the input. Okay, so let me go ahead and view the view DB here. So you can go to DPL specs. As you can see, the word list here is the input for that map, right? It is one of the input partition, and you can see um, that the word list for the input partition 1 has 6 rows in it, right? Okay, so let's go ahead and look in the second uh, data node over here. Let me log in again to collection DPS. So that's the word list, and you can see there is three rows here. Okay, so the input has been partitioned into two tabs or two chunks, let's say. Okay, and so those two input partitions are sent as input for each of the maps. Okay, so in this case, these three rows are the input for the second map. Okay, and then for the first map, we already saw what was the input. Okay, so this is the input for the first map, right? So there are two maps here because there are two partitions. Okay, all right. So that's the input for each of the map word length calculator. And what is the output here for each of the map word length calculator? What was the output generated? So let's look at the output, guys. If you see here, word length calculator. So this is the output of the first map. Okay. So here we still keep the key because we want the key to be unique. So we still keep the key, the original key, and then the length. The length is for each word. What is the length, right? So 4, 5, and so on. The reason that I did not make it as just length and word is because the length can be a duplicate. So, but in our model, we enforce that the key should be unique. So that's why I kept the key from the input. Okay. So the combination of key and length in this case is the keys. The two keys are unique. Okay. All right. So that's the output from the first map of word length calculator. So let's look at the second one. Okay. output of second map is this one right here. Again, I already mentioned to you why we have the key kept here, right? It's exactly the same structure except that the data might be different, right? So from the output of the word length calculator is created using the messenger table, right? In other words, like how does all the output from the data node bind it to the output port of the task, right? So that's the question. So what I did was, each data node will send its output to the to the master node. Okay, so there is something called a messenger table. I'll show that to you. Um, okay, so you have this table here called messenger. As you can see, there is IP address of each of the machine here. You can see each machine sent its output to the master node, right? So in this way, we know that the data node finished its execution and then sent its output, and the output is logged in this table, right? So after the workflow executed, after completing the execution of the task in all the data node, then we will come here. The master node will look at all these output generated for that particular task. So in this case, we executed word length calculator, right? We are looking at these. So these are the three outputs that we received from the data nodes. And then we apply a union on all these three data nodes. Again, these three outputs are collections. So we apply a union, and then we get the final result as a collection and bind it to the output port of the task. Okay. So if you look at the collection of DPS, okay, so these are the three results that came from each of the machines, right? So that's the first one, which is empty because that data node was never utilized, and this is the second one, and this is the third one. Okay, so as you can see, there is three rows here, and then there is six rows here. So the union of them is 9 rows, right? So you can see the output of that is created here, which is 9 rows. Okay, so the output is a collection, and you see that it's 9 rows. Okay, all right. So the this is how we solve the challenge of the output combining all the output from those individual data nodes. Okay, so the next thing I will show the output collection from word length data is sent as the input to count words by length task, right? So according to our workflow, you have seen that the output of the word length calculator is sent to count words by length task. Okay, so that's just an observation there, just a remark. So the next thing is I'll show all the input partitions for radius. The length is the key here, reduced by length, and then count word by length is the task. Okay, I'll show all the input partitions for that in a minute. So let's go ahead and again go to our so this is it. So this was the output, right? The output that we received from word length calculator. If you remember, there were 9 rows, and then for each of these rows, we have mapped it to a data node. Again, here you see that although there are three machines, because of the token distribution in the ring, all these nodes or all these rows are mapped to the same data node, which is number 2 here. Okay, so let's look at the second data. see there are 9 rows here, right? So now we will apply a review. So this is one partition. One partition has 9 rows. Okay. So again, like the reason for that is the token distribution in the ring. According to our token distribution, all these keys are mapped to the um, same node. Okay. So you can see that we have the data here. This is the column. Okay. So the input for reduce length count words by length is this data right here. This is one partition. Okay. So this means that there will be only one reduce job run. Okay. Although like if you have a larger data set, then the distribution will be more even, and then you will have many partitions. And if you have several partitions, then you will have several reduced jobs. Okay. So the output collection. What is the output here? Okay, let's look at the output collection right here. So you can see the output of that is right here. 4 is the name, and then we get all the words that is of length 4, and then 5, 3, and 1, and so on. Okay. So again, there is only one output from the reduced length count words by length. Okay. So then the output of that, the output of the all the reduce, in this case it's just one, will be sent to the output port of the count words by length. Okay. So will be sent to the output port of the count word by length. So I will show you that. If you see here, so the output port of that is right here. Okay. So you can see the data came through from all the data nodes. In the reduce is just one, so it came from that, and then it came to the output port of the task. Okay. So now let's go ahead and look at in ETL stack. You can see there is two data sets presented here, right? BP0 and BP1. Okay. The output of the C workflow is same as the output of the count words by length because it is the last test. Okay. So the output of the C workflow is what? Then it will be, if you go to collectional DPS, I already told you. This is the output of the C workflow. I mean, both are the output of C workflow because we have two output generators. So this is the output of the reduce. This is the output of the map. Okay. All right. Thank you for watching this video.